Sketch a graph of f of x, which is equal to x to the power of 4 minus 24x squared, showing the locations of all x-intercepts, turning points, and inflection points. All right, well, if I'm going to have to show these, I'm going to need to find all the derivatives, because this is when the original function is 0, and these can only happen when the derivative is 0, and these can only happen when the second derivative is 0. And in order to really know if there are inflection points and turning points, I'm going to need to know when it's increasing and decreasing to know when it switches over, and I'll need the derivatives for that anyway. So this is the original function, and the derivative would be this, 4x cubed minus 24 times 2x, which would be 4x cubed minus 48x. And the second derivative, f double dashed of x, would be 4 would still be there times 3x squared minus 48, which would be 12x squared minus 48. Okay, so the x-intercepts would happen when f of x is 0. Factorizing would be the go. I can pull an x squared out of both. That'd leave an x squared behind and a 24. And then either x squared is 0, which would make x equals 0, or x squared minus 24 is 0, so x squared is 24, so x would be the square root of 24, but it could be the positive or negative one. Okay, so square root of 25 would be 5, so square root of 24 is just going to be a little bit less than 5. Okay, that's useful to know. All right, let's do the turning points. So you're going to need the first derivative to be 0 this time. So 4x cubed minus 48x would be 0. So, well, they've both got a 4 in them and an x. And that leaves behind an x squared, and a 48 divided by 4 would be 12. Okay, so x could be 0, or x squared minus 12 is 0, which makes x squared equal to 12, which means that the x is equal to the square root of 12 if x is positive, or it could be the negative one. So root 12, well, 9 is 3 squared and 16 is 4 squared, so root 12 is somewhere between 3 and 4. Squaring grows faster the bigger it gets, so 12 is closer to 9 than 16, so I reckon we're going to be about 3.5. Doesn't really matter at the moment exactly where it is. Okay, so to know exactly where the turning points are and whether they're turning points, I'm going to need to know where it's increasing and decreasing. So I'll draw a sign diagram. For f dashed. So these are the options for x. It could be minus root 12, 0 or plus root 12. And I need to know whether it's increasing or decreasing in each of those zones. So when x is down here less than minus root 12, so something like minus 4. Yeah, we've got 4 times minus 4 cubed minus 48 times minus 4. So we get negative here. Okay, and in this next zone, somewhere between here, I think a minus 1 would work. Now it's positive, and then now plus 1. And now it's negative, and now let's try plus 4. And now it's positive. Okay, so it's going down, up, down, up. All right, which is a W sort of shape. That's what I'd expect with a quartic like this, so that's a good start. All right, so now let's do the inflection points. We need the second derivative to be 0. Okay, well, there's only one x, so I reckon I can do this. Divide by 12. Aha. Square root of 4 is 2, and if it was negative, it would have to be minus 2. Right. Cool. So let me draw a sign diagram for f double dashed of x. So minus 2 and plus 2. So let's see, let's pick minus 3. 12 times minus 3 squared minus 48 is positive. X equals 0 is between these two, and that'll make that negative 48, which is negative. And then I guess if I take that minus out, it's not going to make a difference. Yep, positive. Okay, so it's concave up here and concave down here and concave up here. Well, I think I have enough information to draw the graph, except that I don't know the actual function values at any of these points. I mean, I do for here because it comes out to 0. So I'm just going to figure them out. Let's see, f of 0 is 0. We knew that one already. So that's this turning point here. F of root 12 is root 12 to the power of 4 minus 24 times root 12 squared. Well, root 12 squared would be 12. And to the power of 4, I could do the power of 2 and then another power of 2. So we'd get 12 and then 12 squared, which is 144. So I reckon we're going to get minus 144 there, because this is 12 times 12 and this is 2 lots of 12 times 12. But just let me check that. Okay. And then f of minus root 12 would be minus root 12 to the 4 minus 24 times minus root 12 squared. And the power of 4 will make that minus go away, and the power of 2 will make that minus go away. So I'm going to get minus 144 again. Okay, cool. And now the inflection points, which were minus 2 and 2. F of minus 2. So f of 2 would be 2 to the power of 4 minus 24 times 2 squared, which would be 16 minus 24 times 4, which is also negative. Minus 80. And this one would be minus 2 to the power of 4 minus 24 times minus 2 squared, which should also work out to negative 80 as well, because the 4 will make the minuses go away and it should be the same answer. Okay, so I now have a diagram with all the important things it should be doing. It should be crossing the x-axis at these places. It should be having turning points at these places which have these y coordinates, and it should have an inflection point at these places which has these y coordinates. So let's see. So here's my sketch. It's mostly negative, isn't it? So let's put most of it down here. It's supposed to go down to 144. So if this is like 80, and this is like minus 160, minus 144, 100, 120, 140, it's about here. Okay, so let's see. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here at almost minus root 5, it crosses. and over here, and it meets there as well. And then here when x is 0, there's a turning point. And then what is the next one? Minus root 12. Root 12 was about 3.5, wasn't it? 1, 2, 3. And then minus 80, so that's about there. No, the 80 is the wrong one. Minus 144 for that one. And then at root 12, 1, 2, 3. That was also at minus 144. And then the inflection points happened at minus 2 and plus 2. Okay, and so it's concave up here, and concave down here, and concave up here, and then decreasing, increasing, increasing, decreasing, decreasing, increasing, like that. Cool, and that's my sketch. I've got all the information together, and that's the sketch.